Hey, sixth grade, how's it going? Hopefully you're doing well. Today what we're going to be doing in class is just understanding percentages just a little bit better. It's the same concept that we were doing before, but this time what we're going to be doing is finding the percentage of a quantity that could be more than 100%. Okay? This is a concept that is relatively foreign to you, I'm sure, and that's why we need to spend quite a few weeks on this concept. Okay? It's going to be very different than what we're normally used to. What you're used to is seeing percentages that are between 0 and 100. Now, last time we looked at trying to track percentages on a bar model, which gives us a better understanding of the visual aspect of what a percentage actually equates to. So we could find percentages that are 5%, 10%, even up to 67.5%, okay? And we've used really interesting examples of chocolates and students and other examples, right? But why do we use percentages in the first place? Well, if you take a look at that second paragraph, it says that percentages are applied to different fields. They could be for accounting or finance, to show interest rates, profits, sales, taxations, and several different fields of study use percentages to understand if the data is going up or down. They're also used in concepts like probabilities, nutrition facts, downloading processes, and other types of things. Okay? Here are some terminology, vocabulary words that you might not be familiar with. We've already looked at fractions and ratios. Those are just other types of proportions, mixed numbers, proper fractions, quantities, and the word distinguish. Okay, we're going to be distinguishing differences between two or more quantities, so that's important to remember. Today we're going to be looking at a video, and these are going to be the two questions that we're going to be looking at, okay? I think it's important that we look at the question before we watch the video. This is the first question, and this is the second question. The first question says, your friend has a bag of marbles, and he tells you that 20% of the marbles are red. If there are 7 red marbles, how many marbles does he have altogether? So we've talked about this in the second class, just to see how we could try to figure this problem out. Several students had their own theories and their own ways of doing it. And then we also looked at the second problem. It says, a high school marching band has 12 flute players. If 8% of the band members play the flute, how many members are in the entire band? I think it's important that we look at the parts, the percentages, and the total. Okay, those 3 parts are very important, and we need to break the numbers up into those 3 sections. Okay? When we look at those problems, boys and girls, it's important that we know that when we're finding the percent of a number, we need to first divide the percentage by the quantity, and then multiply that product by 100. We then put the percentage symbol after the final product, but if the percentage is greater than the quantity, this means that the percent is greater than 100. Now let's look at those 2 examples. We're going to look at the video in just a second. I'm going to play this video for you. Okay, and I will put that video in the notes also, so you can see that on your own.
Grammarly does more than catch errors. With Grammarly, you can find...
All right, let's take a look at that.
Hi, welcome to Math Antics. In our last lesson about percents, we learned that there are 3 main types of percent problems because there's 3 different numbers that could be missing. Those 3 numbers are the part, the total, and the percent. They're just the 3 variables or changeable numbers in the percentage equation. The 4th number is always 100, since that's what percent means, per 100. In the last 2 videos, we learned how to solve problems where the part was unknown and where the percent was unknown. In this video, we're going to learn how to solve problems where the total is unknown, or missing. With this type of problem, you'll be told what the percent is, and you'll be told what part of the total you have, but you'll need to figure out what the total itself is. Here's an example of a problem like that. Your friend has a bag of marbles, and he tells you that 20% of the marbles are red. If there's 7 red marbles, how many marbles does he have altogether? Okay, so how do you know that it's the total that's missing in this problem? Well, the word altogether is a big clue because it means almost the same thing as total. So if the question has words like altogether, or in all, or total, or whole, or entire, those can help you know that you need to find the total. And another way that we can tell is by the numbers that we are given. In this problem, we know that the percent is 20, and we're also told that part of the marbles are red, so we know that the part is 7, so that means that it must be the total that's missing. All right then, so how do we figure out what the total is? Well, using a little algebra, which you don't need to know how to do right here, we can rearrange our percent equation like this. What this new form of the equation tells us is that if we take the part and multiply it by 100, and then we divide that by the percent, we'll get the total. That seems simple enough. It's just 2 steps. Let's try it out on our word problem about the marbles. We know that the part that are red is 7, so step 1 is to just multiply that part by 100. 7 times 100 is 700. And in step 2, we take that 700 and divide it by the percent, which we're told is 20. Okay, 700 divided by 20. Well, we could use a calculator to divide, but this doesn't seem too hard, so I'll just do the division the long way. 20 is too big to divide into the first digit, 7, so we'll need to include the digit next to it as well. Now we ask, how many 20s does it take to make 70 or almost 70? Well, that would be 3, because 3 times 20 is 60. 70 minus 60 leaves 10 as the remainder, and then we bring down the 0, and then we ask how many 20s will divide into 100. Aha! 5, because 5 times 20 is 100, so that leaves no remainder. So 700 divided by 20 is 35, and that means that the total number of marbles is 35. And in a problem like this, you can always check your answer by making sure that the fraction of the part over the total would give you the correct percent. For example, in this case, you can make sure that the fraction 7 over 35 would really be 20%. Now that...
All right, so you saw that that example showed us what part was represented from the percentage that we were given, right? So now we're going to take a look at another percent problem.
Wasn't so tough, was it? Let's see one more example to make sure you've got the procedure down before you try some on your own. The next problem says, a high school marching band has 12 flute players. If 8% of the band members play the flute, then how many members are in the entire band? Okay, so the smaller part in this problem is 12, since there's 12 flute players. And we're told that they make up 8% of the band, so the percent is 8. Again, it's the total that's missing. And to find it, we just need to follow our 2-step procedure. For step 1, we multiply the part by 100. 12 times 100 equals 1200. For step 2, we divide that 1200 by the percent, which is 8. This time I think I'll use a calculator to divide. 1200 divided by 8 equals 150. Great. That means that the total number of band members is 150. And again, you can always check your answer the way we did in the last example. All right, that does it for this lesson. Remember, the key to getting really good at math is to do it yourself. Doing practice problems on your own will help you become a great problem solver. Good luck, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Okay, so that gives you a little bit better understanding of a couple of problems that we did to try to find percentages. Okay, so what we're going to do, boys and girls, now is we're going to take a look at just a couple more problems because I think it's important that we try to find different quantities of percentages. Okay, now we did the video in one class and we did the problem in another class. So I'm going to just take a look at this problem right here that we're looking at right here on the screen. So let's read that. It says Sue saves $400 and May saves $500. express May's savings as a percentage of Sue's savings. Now, before we look at that, I just want to ask you a question. Can a percentage be more than 100%? Well, if you remember, sometimes in some classes you might get more than 100% on a quiz. Now, why is that? The reason is because if the teacher has, for example, 30 problems on the quiz and a bonus problem, and you get the bonus problem in addition to the 30 points, you're going to get a percentage that's bigger than 100%. In other words, 109 is possible if you look at the data and compare it to a different possibility or a different set of data. We're looking at two different sets of data, okay? So in this example, we might come up with a percentage that might be bigger than 100. Let's take a look at it. Let's read the problem. It says, Sue saves $400 and May saves $500. So what I'm going to do is just express, first of all, let's express, oops, I did not want to do that. Let's try that again. Let's go here. There we go. Sue and May both have an amount of money. We know that Sue's amount is $400. And May's amount is $500. Okay. We can compare those two amounts because they're both looking at the amount of money. All right. Now, if we take a look at Sue's amount and we compare that to, let's say, 100%, I can change this 100% into a pictorial representation, in other words, a bar model. Okay, this bar is going to represent 100% of Sue's savings. Now, we don't know how much percent May has. We really have no idea. We have to try to figure that out. Okay, so just like our other two examples, we know the part and we know the percent, but we don't know the second percent. We don't understand so far what percent of May's savings is Sue's savings. But we can draw a bar. Now, since I know that May's savings is much bigger than Sue's savings, my bar is actually going to be bigger. I'm going to actually stop right here, and I'm going to continue in a second color, just so I can show you that this amount is going to be a little bit bigger than the previous amount. Okay, so we have May's amount is 100%, but Sue's amount is 500%. I'm sorry, $500. Okay, so this extra amount is going to represent the extra amount of money that May has. Okay, if this right here is 100%, then what would this amount be? How do we try to figure that out? Well, we could set up our proportion like we've done before in the past. What we could do is take $400, which equals 100%, and we can compare that to $500. And we don't know how many percent that is. We have no idea. Okay? So let's try to figure that out. We could cross multiply and divide if we really wanted to. And we could also set this problem up in a different way. This is just one of the ways that we could set it up. Okay? What I'm going to do is just simplify my problem because that will help me divide later on. I'm going to divide everything by 100. Okay? So we have 4 over 1 divided by or equals 5 over some number. Okay, I'm going to cross multiply and then divide. Okay, so 1 times 5 is 5. And then I'm going to divide by 4. Okay, 5 divided by 4. 5 divided by 4 is, I believe, 0.25. Let me just make sure. 5 divided by 4 equals, okay, here we have 1.25. All right, so this is actually going to be 1.25, which equals my the amount right here, this amount right here, plus the extra amount. So since I know that this is a decimal, I can multiply by 100 to get my final percentage. If I multiply by 100, that's just the same as moving my decimal point over 2 spots. And we have 125% as my full percentage that represents May's savings. Okay? If I wanted to do that in a different way, I could also do that in a different way. Let me show you a slightly different way. Instead of putting 100 on the bottom, I could always put 100 on the top. Okay, I could just put my percentages on the top and my amounts on the bottom. So let me just show you that. Okay. So initially you put the amount on the top. This time we're going to put the amount on the bottom. And let me show you just a slightly different way. Okay. Let's have now our 100% is equal to $400. Okay. And we know that that equals some percentage over $500. All right. I'm going to do the same thing I did before just to simplify these numbers. I'm going to divide everything by 100. Divide 100 by 100, 400 by 100, and 500 by 100. My new proportion is going to be 1/4. It's the same as some number over 5. All right. Now I'm going to cross multiply and divide just like before. 1 times 5, and then divide that by 4. Let's try this on the calculator again. 1 times 5 is 5. And divide that by 4, we get 1.25. Okay, so it doesn't really matter how we do it. We can try to figure that out in a lot of different ways. Okay, there's lots of different ways we can set this proportion up. If we multiply this by 100 to get our percent, it's the same thing as moving our decimal point over 2 spots, and we have our percentage, 125. In other words, this portion right here equals 25% because 100 plus 25 equals 125. So if we're trying to express May's savings as a percentage of Sue's savings, May's savings equals 125%. Okay, so just like before, our question was, could we have a percentage that was larger than 100? We sure can. So we're going to go through more examples like that at a later date next week, but that just gives you a taste of what we're going to be going through. So we will talk to you guys later.